Good evening, students. Welcome to Chemistry Online Bridge class. Myself, Devendra Papatil. Today, in this session, I will discuss one of the fundamental basic chapter in chemistry, that is chemical reaction and equation. Let me tell you overview of this chapter, chemical reaction and equation. See, where in this chapter you will know the first thing, what do you mean by chemical reaction? Chemical reaction. Chemical reaction. You know, students, various different types of chemical reactions that can take place where in our day-to-day life, even where in our body too also, where in the nature. And you know, some of the chemical reactions are there we can easily find out with our naked eyes. And some of the chemical reactions are there, it is very difficult to identify with our naked eyes. Very difficult. Therefore, where in this chemical reaction, how to recognize the chemical reaction or how to identify the chemical reaction, that one also you will be knowing where in this chapter. The first one you came to know the chemical reaction, where in that how to recognize the chemical reaction. Coming to the next one, chemical equation. Chemical equation. So what is this chemical equation? Whatever the verbal statement of a chemical reaction is there, that verbal statement of a chemical reaction, that is to be written in the form of again word equation, again word equation to chemical equation form by using symbol of the chemical substance and formula of the chemical substance that are involved where in the chemical reaction. So chemical equation means what, or what do you mean by chemical equation, that one also you will be learning. Next one is how to balance the chemical equation, because balancing the chemical equation is very important to fully fill the law of conservation of mass, or balancing the chemical equation, it is in accordance with law of conservation of mass. That why how to balance the chemical equation, that one also you will be learning, followed by various different types of a chemical reactions. Is it no? That may be chemical combination reaction, chemical decomposition reaction, chemical displacement type of a reaction, or double displacement type of reaction, redox reaction. Even you take isomerization reaction is there, polymerization reactions are there, various different types of a chemical reaction, followed by corrosion and rancidity. These are the things that one you will be knowing where in this chapter student. Now coming to the next, see here, you know that what do you mean by chemical reaction? Let us take students this example. If I am taking liquid water, on heating, what happens? So you will get water vapors. Water vapors. Whether this reaction is to be known as a chemical reaction? No. Why means only there is a change where in the physical state of the involved substance, but the chemical composition it remains same. Here also water, here also water. Such types of a changes are known as physical changes. And you know physical changes are temporary. Therefore, we can't take this one as a chemical reaction. Chemical reaction. Let us take the one more reaction. You know ammonium cyanate NH4CNO. Again, this ammonium cyanate being an inorganic substances, on heating it gives urea, that is NH2 C double bond O NH2 student. This is known as what? Urea. Urea. So this is ammonium cyanate. Ammonium cyanate. So let us see here, entirely a new product that is formed with a different properties. Different properties. Properties of urea and ammonium cyanide entirely different. This is being inorganic chemical substance. On heating it gives urea, that is organic compound. Therefore, properties of the reactant, and if you are going to take properties of the product, entirely different. There is a new product, that is formation of a new product that will take place. So both these are known as isomers because both are having same molecular formula. But on heating, due to the rearrangement, what happens now? A new product that is formed. Formation of a new product. Even such types of reactions are known as isomerization reaction. This is an example for chemical reaction. But here only there is a change where in their physical state, but the new product formation does not take place. That means this is physical change. This is chemical change, we can say. And if you are going to take C here I have been taken one of the reactant, which is that one methane. So when methane is heated in presence of oxygen of air, you know the product formation, that is carbon dioxide and water, that one take place. Actually, it is known as combustion reaction. Hydrocarbon compound, it burns in presence of oxygen of air to form carbon dioxide and water molecule. And here methane and oxygen, both these are known as reactant. Where in a chemical reaction, both these are known as reactant. You know, reactants combine together to form a product. What happens actually where in a chemical reaction? Breaking of the old bond, formation of a new bond that take place. New bond that take place. Is it correct now? So here what I have been taken, reactants are there. These are the product. You know, reactants, these are get separated by using plus sign. So if there are more number of reactants are there, generally we can take A plus B plus C. These are the reactant. Assume now. So product even I can take D plus E plus F student. Is it correct? Therefore, between the reactant or reactants are separated by plus sign. Even between the product also we are using plus sign. And you know, reactants combines to form product. Both the reactants and product, these are get separated by using an arrow mark. You see, an arrow mark. What it shows now? Reactant gives rise to the product. And you know, chemical reaction means it is a process in which one or more reactant are converted into one or more product. So reactant combines to form a product. And during a chemical reaction, what happens now? Chemical change that take place. You know, chemical changes are permanent, not temporary. And here, whatever the substance that is undergoing the chemical change, I mean methane plus oxygen, it gives rise to the carbon dioxide and water molecule, you know. But methane and oxygen, both these are known as reactant. Why? Means they are undergoing chemical change. And if the chemical substances, if these are undergoing the chemical change, these are known as reactant. And whatever the new product, I mean a new substance it is going to form, where on the right hand side, product formation side. So here we can see the new substance which are formed where in this reaction, one is carbon dioxide, another one is water molecule. Therefore, these are known as product and these two are known as reactant. Reactant and product, that these are get separated by using a point, an arrow mark. It shows reactant combines to form a product. That one you have to remember. Now coming to the next one. So few example now I will take regarding the examples of a chemical reaction. You know students, lead nitrate whose formula is PbNO3 taken twice. Lead nitrate. So I've been taken a lead nitrate where in a test tube. So aqueous solution of that lead nitrate. So to that if you are adding potassium iodide, potassium iodide. Now there is a formation of a lead iodide, that one you can see. Lead iodide PbI2, PbI2, lead iodide. Along with that, what you will get? Potassium nitrate, KNO3, KNO3. Here only I wrote which are the reactant, which are the product here. But one thing you have to remember, this chemical reaction, it is not a balanced chemical reaction. So these two are known as reactant, these two are known as product, student. We will learn how to balance, why to balance the chemical reaction. And if you are going to see this lead iodide, it is in the form of a yellow precipitation. It settled down where in a test tube, because in a test tube I have been taken lead nitrate, to that I am adding potassium iodide, potassium iodide. So let us balance here only 2 Ki, so this is 2 KNO3. Later we will go through the stoichiometric coefficient of both the reactant and product. But anyway, see here student, how to recognize the chemical reaction. Here there is a change where in the color. There is a change where in the color. So because of that reason, there is a chemical reaction. So both these two react, combine with each other, and there is a formation of a yellow precipitation that is known as lead iodide, along with what you will get means potassium nitrate, student. That one you have to remember. So here we are recognizing the chemical reaction. There is a change where in their color. So colorless to yellow precipitation. Hence, this is also a chemical reaction. Actually, what happens, see here. Again, there is a rearrangement. Whether the different atoms of an elements are there? No. Lead is there, nitrate ion is there, potassium ion is there, iodide ion is there. Only rearrangement of these ions that one take place. It means that breaking of the old bond, formation of a new bond with a new product, with a new chemical properties. Entirely the properties of the reactant and the properties of the product is different where in a chemical reaction. That why it is known as a chemical change. It is permanent. Now coming to the next one more example for a chemical reaction. You know that. So let us take a zinc granules or a piece of a zinc metal 2 also. If you are adding a piece of a zinc metal where to the diluted hydrochloric acid or diluted sulfuric acid, student. So we have been taken a diluted hydrochloric acid or diluted sulfuric acid in a test tube. To that we are adding a small piece of a zinc metal, student. So let us see what happens where in this case. If you are going to take HCl, here it is taken S2SO4. Now I am taking hydrochloric acid. What happens? Now it gives rise to zinc chloride along with the evolution of a liberation of a hydrogen gas here, student. Hydrogen gas. Is it correct? Now let us take 2HClH2. Here only just I balanced. Again I will explain. Let us see, this is also chemical reaction. How to recognize, how to identify means through the liberation of a gas or through the evolution of a gas, you can identify more clearly. Here which gas is evolved? Hydrogen gas, that one is liberated, that one is evolved. Here also what is taken in a conical flask means diluted sulfuric acid is there, student. Zinc granules are added. You know there is a cork, but so inserted, which one? Glass tube. It is not packed one, it is open. Which one? The glass tube. So hydrogen gas, it will escape through this glass tube. It means that it is a chemical reaction. See here, hydrochloric acid, zinc, when they react, formation of a zinc chloride, these are the reactant combines to form a product. That one you have to remember. Now coming to the next one. Here I have been taken a how to recognize or how to identify the chemical reaction. One you already came to know. See, first there is a change wherein the physical state of the involved chemical substances in a reaction. Maybe solid substances get converted into solid along with what? Gas that is liberated. For example, if you are going to take now CaCO3, so the reactant were in a solid state. On heating, thermal decomposition, it gives rise to CaO. This is solid form. Along with that, you will get CO2. This is a carbon dioxide gas. That one is liberated CO2 gas. This is CaCO3. So calcium carbonate. So on decomposition gives calcium oxide through the liberation of a carbon dioxide gas, student. One thing just you have to remember, see, where in this case, even there is a change where in the physical state of the reactant and the product. Here solid substances gives rise to the solid along with gas. So we can identify, we can recognize. Already we came to know change where in the color also, and evolution of a gas. Here also you can identify, you can see. One more is there, that is change in temperature. Some of the chemical reactions are there. So the product formation, that one take place through the absorption of a heat energy. The product formation, when in some of the chemical reaction, that one take place through the energy released, energy absorbed, energy released. It means that there is a change in temperature also, that one we can see. So these are the few what you call know that how to identify, also we can say how to recognize change in the chemical reaction. One is change in physical state of the involved substance, change in color, evolution of a gas, even change in temperature. So whether energy is it released or energy is it absorbed, whether is it a endothermic reaction or is it a exothermic reaction, all these things. So it helps us to recognize the chemical reaction. Okay. Now coming to the next one. I've been taken here chemical equation. Everybody you know that one chemical equation is nothing but shorthand representation of a chemical reaction by using symbol and formula of the chemical substances involved where in that chemical reaction. Shorthand representation of a chemical reaction. See students, if you are going to see this simple equation, I mean a chemical reaction, it is given in the form of a word equation. Even first verbal statement that is converted into word equation form. What is that verbal statement? A magnesium metal, it react with oxygen of air. The description of a chemical reaction can be written in a shorter form. It means that first verbal statement, when a piece of a magnesium metal is heated in presence of oxygen of air, it gives magnesium oxide. Magnesium oxide, a white powdered form of a magnesium oxide, but it is time consuming. Which one? The verbal statement. That was again, this verbal statement is converted into word equation form. Word equation means here also we are writing name of that chemical substance which are involved where in the reactant, and which product is formed where in the product side. Here magnesium react with oxygen gives rise to magnesium oxide, student. So you know, reactants are always written how to write a chemical equation and how to balance the chemical equation, why to balance the chemical equation. You know, reactants are always written where on the left hand side with a plus sign between them. We are inserting plus sign. So it shows here left hand side magnesium plus oxygen is there. Therefore, these are known as reactant. And products are written always where on the right hand side, you know, with a plus sign between them. Suppose if there is a two products are there, between the two products you have to insert plus sign. The arrowhead point, see this is important, arrowhead, arrow mark, arrow-headed, arrow mark, arrowhead, what it shows? No, the arrowhead, the point towards the word product. It means that reactant combines together to form a product. That one you have to see. So it shows the direction of the reaction, which side that is taking place. Which one? This arrow headed points towards which side it is there. Product formation side is there. That was reactant. It gives rise to the product formation. That one you have to remember. Therefore, always all the reactants that are to be written were on the left hand side. The product which are formed in that chemical reaction that is to be written were on the right hand side. So more than one reactant is there means these are separated by using a plus sign, inserting a plus between them. More than, so one product formation take place means that is also separated by using a plus sign between them. Okay, and between the reactant and product, you know, there is a arrowhead points that one take place towards always product formation side. So this is way of writing which one chemical equation. Let us say writing a chemical equation. Word equation is converted into again chemical equation. That word equation is also time consuming. First verbal statement to word equation form to chemical equation form. That one you have to remember. Let us see what happens. So chemical equation can be simplified by using chemical formula. Chemical formula means that may be symbol of an element if it is an element, or the formula of the chemical substance that are involved where in that reaction. We are using either symbol or a formula which are involved in the chemical reaction, which purpose to write a chemical equation. That why it is known as a shorthand representation of a chemical reaction by using a symbol and formula of the chemical substance that are involved in the chemical reaction is known as a chemical equation. Let us see here. So magnesium, symbol of an element magnesium, Mg plus O2, it gives rise to MgO. If the number of atoms of each element is not same, where on the left hand side and right hand side, the equation is unbalanced. That is very important. It is known as a skeletal chemical equation. If same, it is balanced. How? What is the differences? That one we can see. This is known as a unbalanced chemical equation, student. This is known as a balanced chemical equation. Question arises, why we have to balance all these things? See here, one magnesium atom is there, it react with oxygen molecule, student, here oxygen molecule, so oxygen, it exists where in the atmosphere in the form of a O2, but not where in the form of atom. That means, so here what is taken now? Magnesium metal, it react with oxygen, it gives magnesium oxide, a powdered, white powdered form of a magnesium oxide. Is it balanced? No, it is not balanced or unbalanced. But we have to write a balanced chemical equation always. You may ask a question, why we have to balance the chemical reaction, or why we have to write a balanced chemical equation, student? Balancing the chemical equation, that is in accordance with law of conservation of mass, one of the important law wherein the laws of chemical combination. So first one is the law of conservation of mass. So this law of conservation of mass, what it says? No, this is given by law of conservation of mass. Law of conservation of mass. This law, it is given by Anthony Lavoisier. According to this law of conservation of mass, what we came to know, during any physical process or a chemical process, total masses of the reactant remains equal to total masses of the product. This is the statement of a law of conservation of mass. Or matter, listen to me very carefully, I am telling matter, the word matter, neither be created nor be destroyed where in a reaction, chemical reaction. Therefore, total masses of the reactant, that must be equal to total masses of the product. Then only it is a balanced chemical equation. And this chemical equation, it is not balanced, hence it is known as unbalanced or skeletal chemical equation also we can say. Why? See, students, atomic mass of magnesium is how much? That is 24. I am taking in terms of a gram. You will be learning same that atomic mass, just I am expressing in terms of a gram atomic mass. 24 gram I have been taken, students. What about the oxygen? The molecular mass of this O2. There are two oxygen atoms are there. This is a molecule of oxygen. Is it correct? No. So 16 into 2, that is 32. 32 gram I have been taken. Coming to the product side, only one magnesium atom means atomic mass is, so 24 plus only one oxygen atom is there, students. That was I am taking here 16. I am taking 16. Let us see here. 24 plus 16, 24 plus 32. Whether the total masses of the reactant is equal to total masses of the product? No. That means we have to balance this chemical equation. That was balancing the chemical equation is in accordance with the law of conservation of mass. Now, how to balance? Now here, don't write. Most of the students here you are writing, so here also O2 you write, sir, Mg2 balance. No, it is not like that. Magnesium, it exists where in an atom form. Atom form. That was, so if you are taking 2 Mg plus O2 gives rise to 2 MgO. 2 MgO. Here, how many magnesium atom have been taken? 2 are there. Atomic mass of magnesium is how much? 24. Then what you are doing? 24 into 2 you have to do, students. Then both these two you have to add. Here 24 plus 16. This is multiplied by how much? 2. 100%. So total masses of the reactant, that is equal to total masses of the product. That one you can see. Very simple. This is nothing but how much means here. So 4 2s are, that is 8. 2 2s are 4. 48 gram of the magnesium. And this is 32 I am taking. Suppose if you are adding 48 plus 32, 8 plus 2, that is 10, carry 1, that is equal to how much now? 80 gram you will get. So 24 into 2, that is 48 gram plus 32. Coming to this side, you know already 24 plus 16 is there. So 6 plus 4, 10, carry 1, 40. Yes, students, 2 into 40, this is again how much means? This side 80 gram, that side also 80 gram. 80 gram, so 80 gram. So total masses of the reactant is equal to total masses of the product. That one you can see. That way it is known as a balanced chemical equation. This is unbalanced chemical equation. Coming to the next one, let us see here also. It is given already to fully fill the law of conservation of mass, everything, law of conservation of mass, everything, that one we already discussed. Let us see here, number of atoms of each element remain the same before and after a chemical reaction. So skeletal chemical equation must be balanced. Word equation, if you are going to see, one more reaction is there. We have been taken here, zinc is there. Zinc react with sulfuric acid, gives rise to zinc sulfate and hydrogen. So the chemical equation is, word equation is converted into chemical equation form. What we came to know here, zinc is there, Zn plus S2SO4. It gives rise to Zn SO4 plus S2 is given. Now how to check, how to confirm whether is it a balanced chemical equation? Let us see first number of atoms were in the reactant side, left hand side, how many are there, number of products were on the right hand side. If you are going to take a zinc only, so here how many atoms of zinc? One atom of zinc is there. What about the hydrogen? Where on the reactant, left hand side, reactant side, 2 are there. So what about the sulfur atom? 1 is there. Oxygen, 4 is there. Okay. In the same way, number of atoms you can see where on the product side, right hand side. So zinc, 1 atom is there, 1, 1. What about the sulfur? In this case again 1. Oxygen again 4. What about the hydrogen? 2. Therefore, number of atoms were in the reactant as well as also number of atoms were in the product, they are remain same. That way we can say this is a balanced chemical equation. See students, one more thing we can observe very carefully in a chemical reaction. Actually what happens now? Rearrangement, that one take place. Whether any new chemical, okay, new product formation is there, but whether different types of atoms are there, where in the product formation by seeing the reactant, whatever the atoms are there in the reactant, same thing, that one we can see where on the product side. Only thing is reorganization, rearrangement, that one take place. Therefore, breaking of the old bond, formation of a new bond, that results in the new product with a new chemical properties. Hence, it is known as a chemical reaction. That one you can see. Now, coming to the one more example we will take. This is given, you know, iron metal. So, iron metal react with a what? Steam here. So, steam we have to take. Steam is nothing but water vapor, students. So, where on the iron metal, if water vapors are passed, no product formation that is given, that is known as Fe3O4. You know this Fe3O4, it is a mixed oxide of iron, we can say. Why I am telling this one as a mixed oxide? It is the composition of FeO plus Fe2O3, student. You will be learning. This is ferrous oxide plus ferric oxide gives rise to magnetite, Fe3O4, magnetite we can say. So it is a mixed oxide form, ferrous oxide plus ferric oxide, ferrous ferric gives rise to Fe3O4. So mixed oxide form of a iron metal. See here, iron plus water, Fe3O4 plus S2. You have to balance. Step 1, so draw boxes around each formula. Do not change anything inside the boxes that is given. Leave about that. This is the first you are writing. This is important. Step 2, first you write number of atoms in the reactant side, number of atoms where in the product side, how many are there. Only iron is there, hydrogen is there, oxygen is there, element no. The number of atoms where in the reactant side, iron atoms how many are there? 1. What about the hydrogen? 2 are there. Oxygen 1 is there. If you are going to see product formation side, see students, number of atoms where in the product side 3 are there. Now hydrogen atom 2 are there. If you are going to see oxygen 4, whether is it a balanced? No. So this is not a balanced one. How to balance? Let us see. Step number 3. Select the compound having maximum number of atoms. Maximum number of atoms. So in that we came to know that one maximum number of atom is oxygen. In the reactant we came to know already, see here in this case. So in the reactant oxygen only 1 is there. Maximum number of atoms oxygen, where in the product side how many are there? 4. That means what you have to do? You have to multiply. See here, where? For the water. Which purpose? To balance the oxygen atom, you are multiplying by 4. I mean the stoichiometric coefficient, how much we have been taken? 4. 4H2O I wrote. Okay, 4 oxygen atom, here 4 oxygen atom. What about the iron? Here 3, here only 1. Here hydrogen, how many are there? 2 are there. But you know, 4 2s are 8 hydrogen atoms are there now after multiplying by 4. So, which purpose? To balance the oxygen atom. Here, maximum number of atoms we came to know oxygen. First, we are balancing the oxygen. Now, coming to the step number 4. Balance the number of hydrogen atom. We came to know, see here, 4 2s are 8, where in the reactant side hydrogen atom, but in the product, now we are multiplying by 4, 4 2s are 8. It is again not balanced completely, partially balanced, students. That one you have to remember, where in this case. Now, if you are going to observe very carefully, which is left out, iron atom is left out, students. Fe3. Here, so only one iron atom in the product side. In the product side, we came to know how many? 3 are there. Therefore, I am multiplying by 3 Fe. So, stoichiometric coefficient is how much now? This is 3. So, balance the number of iron atoms. So, what we came to know overall? 3 Fe plus 4 H2O, it gives Fe3O4 plus 4 H2O. 4H2O. 3Fe plus 4H2O gives rise to Fe3O4 plus 4H2. Now it is a overall balanced chemical equation, student. Like this, you have to follow all these steps. You have to balance individual atoms, whereon reactant as well as also product side. So initially only one iron atom is there, one iron atom. Now we are multiplying by 3, 1 into 3, that is 3. So hence in this way, all the individual atoms that are balanced, both were in the reactant and product side. No, this is a balanced, we can say, chemical equation. Now, the thing is that to make it more informative, that is also very important. Only writing the balanced chemical equation. So, afterwards, we have to see the physical state of the involved chemical substances in that reaction, whether they are in a solid state or gaseous state, liquid state, aqueous form, or there is a evolution or a liberation of a gas. Each and everything, that one you have to see. That means this one, it gives more information. Your chemical reaction should be more informative. How to make informative? Count atoms of each element on both sides of the equation to check the correctness. We came to know balanced equation. Okay. See step 7. If necessary physical states such as gases, liquid, aqueous, solid state are included in a chemical reaction. So here iron is in a solid form. Water, vapors, I said steam it is. not a liquid water, it is a steam. Then it gives rise to formation of Fe3O4, magnetate ore composition, plus 4H2. So hydrogen gas, that one is liberated. Here you see here, aqueous means reactant or a product present as a solution in water. S2O gas, what it indicates, no, water is used in the form of a steam. It is used in the form of a steam. So these are the things also you have to remember, you have to go through. Now, even sometimes here in some of the reaction conditions we have to mention. That is very important. Reaction conditions is to be mentioned. Where it is to be mentioned? Where on the arrow mark? These are indicated. Which types of a reaction condition? That may be temperature, that may be pressure, that may be presence of a catalyst. Everything, that one is to be mentioned. Let's see, these conditions above or below the arrow mark where in the equation that are to be represented. Here we have been taken a carbon monoxide react with a hydrogen gas at what pressure? Here pressure 340 atmospheric pressure. It gives rise to methyl alcohol. Here carbon monoxide physical state is in a gaseous state, and your one more reactant, that is hydrogen gas, is also in a gaseous state. Your product formation is methyl alcohol or methanol. The alcohol is produced as a product where in this reaction, these are the reactant. So at this atmospheric pressure gives rise to the formation of methyl alcohol. In this reaction also you have to see carbon dioxide with water, that one is given. Water, carbon dioxide, this is to be where it is to be taken. Aqueous means humidity. Actually you know where in an atmosphere carbon dioxide gas that is available, student. Is it correct? No. So who are responsible? We are responsible because we are inhaling oxygen, exhaling carbon dioxide. That is also a chemical reaction only, because O2 we are taking inside, we are leaving CO2 outside. O2, CO2. So different types of a, so even we can see the formation of a product and which are the different types of a reactant and product also we can observe. But you know, in presence of a sunlight, all the plants, they will prepare a food, photosynthesis reaction. So in presence of a chlorophyll, one of the pigment, and by using sunlight, so carbon dioxide and water gives rise to what you call glucose. This is known as, so photosynthesis reaction 2 also. Here we wrote O2 plus water. This is in aqueous, means some moisture will be there. It is not a dry oxygen gas, it is a wet. That was aqueous, along with what? Water, that is represented. So apart from that also you can see here, one more we can go through before discussing this one. So if I'm going to take N2, so it is in a gaseous form. So plus H2, again it is in a gaseous form. Now I am writing 3H2. Okay, it gives the formation of a ammonia. This is the reaction. So manufacturing of a ammonia. Here too also, students, certain conditions that are mentioned, certain condition. So which types of a catalyst we are using? Iron in the form of a iron oxide, Fe2O3. Is it correct? No. 200 atmospheric pressure, even optimum temperature we are maintaining. Optimum temperature we are maintaining because the reaction seems to be exothermic. So even such types of a C, the condition that are mentioned were on this arrow mark. Now coming to the next types of chemical reactions. I said already there are various different types of a chemical reactions. What are all these? With an example that one now we will discuss. So where in these types of a chemical reaction, if you are going to take, see here, first one is In a chemical reaction, atoms of one element do not change into atoms of another element, nor do atoms disappear from the mixture or appear from elsewhere. Then actually what happens now? Here A, B, here also A, B, we can see same type of atoms are there. Only thing is involving breaking and making of a bond between the atoms. Breaking of the old bond, formation of a new bond. You know, chemical bond. That may be a covalent bond, that may be an ionic bond. So chemical bond is nothing but a kind of force of attraction that exists between the constituent particles. That constituent particle, it may be atom, that may be a molecule, or that may be ion, student. So if you are going to see the types of a chemical reaction, first one, this is known as combination reaction. There is a formation of a only one product. So two or more than two reactant combines together to form a single product. Combination, combining all the reactant to form a single product. Second type is also there, decomposition reaction is there. What is that decomposition means? I have been taken a reactant like AB, only one compound I have been taken. This one on decomposition gives rise to the product A and B. Decomposition. That may be a thermal decomposition, or even by using a catalyst we can go through. Here, this is known as displacement type of a reaction. This is a compound or a molecule. So when an atom of an element react with this molecule or a compound, so what happens now? Displacement of a which atom? B from this compound, it takes place, gives rise to AC plus B. This is an example for a displacement type of a reaction. Here AB plus CD, AD plus CB. This is known as what? Double displacement type of a reaction. Only thing is combination. Coming to the decomposition, this is a displacement. Whether is it a single displacement, double displacement? This is a single displacement because displacement of only one atom. Here displacement of both the atoms, that one take place. That was it is known as double displacement. But oxidation reduction reaction is there, students. You will be learning where in the PUC first year, but we will go through. So few example where on this also redox reaction we can say, students. One by one now we will go through. Now coming to the combination reaction. What is that combination reaction? See, that is given the simple example. So where in a beaker water is taken, is it correct now? Then where to this water we are adding quick lime. See there, quick lime. Calcium oxide, commonly known as a quick lime. If you are adding a quick lime, where to the water, what happens now? The slaked lime, calcium hydroxide is formed. Where in the product side? Formation of a slaked lime, calcium hydroxide. But very important thing is, along with that, there is given one more term that is known as plus heat. It means that it is which type of a reaction? Exothermic type of a reaction. That one you have to remember. Exothermic type of reaction. So what we came to know? Calcium oxide combines with water or react with water to form calcium hydroxide, slaked lime. But you know, this calcium oxide reacts vigorously with water to produce slaked lime. So releasing what? Heat. Hence, this is an example for a combination reaction, because wherein this there is a heat energy that one is released. Formation of a product with the evolution of a heat energy, Hence, it is exothermic. Heat is given out. This is an example for combination type of a reaction that one you have to remember, student. Okay. Now coming to the one more example we will go through, where in this, yes, students, here again same only. The slaked lime solution, it appears like in the form that is known as also whitewashing, you know already. But this calcium hydroxide reacts slowly with what? Carbon dioxide. Where it is available? It is there in an atmosphere. When calcium hydroxide reacts with carbon dioxide slowly, what happens? There is a formation of a layer of calcium carbonate. Is it correct? No? How many? After 2 to 3 days of whitewashing, giving a shiny finish to the walls. You know, whitewashing we are doing, that is nothing but a calcium hydroxide only. Slowly, that whitewash, when it is exposed to the atmosphere, so a thin layer formation of a calcium carbonate, that one take place. And see, students, where in this case, calcium hydroxide, which is being aqueous, when it react with a carbon dioxide, there is a formation of a calcium carbonate along with water. That one too also have to remember. This is the formation of a calcium carbonate. This is also known as a limestone, or we can take that one as a marble. Is it correct? It means that, so first of all, calcium oxide, quick lime, when it react with water, so slake lime is going to form, along with there is a liberation of a what? Heat energy is produced. That means this reaction seems to be what you call exothermic reaction. Exothermic reaction. Now coming to the another example where for the combination reaction is given, students. You know, burning of a coal also. And you know, burning of a coal means even you take hydrocarbon fuels, they too also burn in presence of oxygen of air to produce the water and carbon dioxide. Here we have been taken coke. Coke, burning of a coal, a coke even you take. Coal, when it burns in presence of oxygen, formation of a carbon dioxide. Here too also energy is released. We can write plus heat, student, plus heat. Why? Energy is released. That way it is also known as exothermic reaction, exothermic chemical reaction. Formation of a water from H2 and O2. I think so. This reaction, see, some initiation, that one is required, because it reaction take place very vigorously in presence of a catalyst like what? A platinum metal catalyst, which one? Hydrogen gas combined with water. So in presence of a platinum metal catalyst gives rise to the formation of a water. But these are to be taken as best example where for a combination reaction. So A plus B, it gives rise to AB product. So two reactants or more than two reactants combines to form a single product, that is known as chemical combination. Here it is given burning of a natural gas, methane, natural gas we can say. Even you know, methane is one of the important constituent of a CNG, compressed natural gas, methane gas. So in presence of oxygen gives rise to carbon dioxide plus water. Here even heat is released, energy is released. Even tremendous amount of energy is produced, students, where in this reaction too also. And we have been taken the respiration, because see, students, the respiration is also one of the example where for a given thing we can see combination reaction only given. But in this case, if you're going to see, so carbon dioxide along with water is there, energy is also released. But this one I will take best example for exothermic type of a reaction. Exothermic reaction. Exothermic reaction. But don't take here combination type of reaction. The other examples of a exothermic reaction better, because I've been taken as A plus B gives rise to a single product. Let it be. But here all these are the best example where for the exothermic reaction. Again, I am making more clear exothermic reaction. Even decomposition of vegetable matter into compost or burning of a magnesium to form magnesium oxide, all these are given. Okay, so these are the best example for exothermic reaction. Now coming to the second type, that is known as decomposition reaction. What is meant by, or what do you mean by the term decomposition reaction? These are the reaction in which a single reactant break down to give simpler product. Single reactant will be there, so it will break down, breaking of the bond, that one take place to give a simple product formation we can observe. One simple experiment is there. See, 2 gram of a ferrous sulfate crystals in a dry boiling tube is taken. It heated over a flame, green color of ferrous sulfate is changed with characteristic odor of burning sulfur. Something is there. When heated ferrous sulfate Cr, so it loses water molecule, it then decomposes to ferric oxide, sulfur dioxide, and sulfur trioxide. You know ferrous sulfate, FeSO4, there will be 7 water molecules. Hydrated ferrous sulfate we can take. So when you are heating means it is going to lose all its water molecule. Again, whatever the ferrous sulfate will be there, student, that one it undergo decomposition. On decomposition, it gives one is ferric oxide, sulfur dioxide, and sulfur trioxide. Sulfur trioxide. We will be knowing here when ferrous sulfate, solid ferrous sulfate, when it is heated, where in a test tube. So a characteristics odor of a burning of sulfur, that one we can enhance. That one we can see. So if you are going to consider where in this is a best example where for a decomposition type of a reaction. Whether this reaction easy to balance, that one also we will check. Where on the reactant side, 2 iron atoms are there. In the product formation side, 2 iron atoms are there. Iron atoms are balanced. What about the sulfur? 2 sulfur atom here, 1 sulfur, 1, 2 sulfur atom. What about the oxygen? 2 4s are 8, and here 3 plus 2, that is 5 plus 3, 8. It means it is a overall balanced chemical equation. Therefore, ferrous sulfate on heating gives rise to ferric oxide, sulfur dioxide, sulfur trioxide. This is the best example where for a decomposition reaction. Now coming to the next one is, even we have been taken this one already, we came to know, when a limestone, we are providing a heat, thermal decomposition of a limestone gives rise to quicklime plus carbon dioxide. So you know decomposition of calcium carbonate to calcium oxide, so it is used where in industrial side, calcium oxide. Even you come across where in the metallurgical process, students, we are adding this limestone CaCO3 in the form of a flux, a chemical substances that are added to remove the impurities, I mean a gang particles matrix. Is it correct? No. Why means on decomposition, this limestone, it gives rise to lime oxide. Suppose where in the extraction of, let us take here, calcium carbonate on decomposition gives rise to calcium oxide, carbon dioxide, already it is there. Okay. Now what I am taking, this calcium oxide, it combines with silica to form calcium silicate, CaSiO3. This is known as a slag. This is known as a flux. This is known as impurities. Which types of impurities? Acidic impurities. These will be present where in the hematite ore during the extraction of a iron metal by following blast furnace. It means that here this limestone, it undergo decomposition, gives rise to two simple product. One is quicklime, another one is carbon dioxide. Therefore, this is carried out by using a heat. Heat is required. That why it is known as thermal decomposition reaction. Why? Heat is required to carry out this reaction or to break down the calcium carbonate. Now coming to the next. Here are some other examples where for a thermal decomposition is given. You know, students, this is lead nitrate on heating. Lead nitrate. I have been taken here PbNO3 taken twice. A single substance. Okay. So this lead nitrate, it undergo decomposition. What it gives now? One is lead oxide, PbO. Along with that, you will get nitrogen dioxide gas plus oxygen gas is also produced. See here, lead nitrate on decomposition gives rise to lead oxide along with nitrogen dioxide are emitted. This identification of a NO2 gas, A, brown fumes, or we can say reddish brown fumes. Liberation of a reddish brown fumes means there is a NO2 gas. NO2 gas, that one is emitted. Along with oxygen gas is also produced, O2. Even this is also the methods of preparation of a O2 gas by decomposition of a lead nitrate, where in the laboratory, that one also we can say. So now, so coming to the next one, thermal decomposition, another example is given. See here, this is known as electrolysis of water. Electrolysis of water. Electrolysis means decomposition of an electrolyte. You know, electrolysis, that is to be carried out by using electrode, wherein electrolytic tank. For that, electrolyte is required, student. Electrolyte is nothing but the chemical substances which undergo decomposition, or the electrolytes are the chemical substances, they conduct electric current either in a molten state or in aqueous form. Also we can say electrolyte. But the question is, electrolysis of water we are doing how? So you know that one, this is a plastic mug. There will be two holes we have to drill, and we have to fit rubber stopper, and we are inserting two electrode, carbon electrode, in that rubber stopper. Okay, and these two electrodes are connected where? To the battery. How much? 6 volt is applied. Okay, fine. Here what is taken? Water is there, so two graphite rods will be there. One, it act as anode electrode. This is anode electrode. This one, it act as cathode electrode, student. Cathode electrode. And fill the mug with water such that electrodes are immersed. Add few drops of Ca to acidify. Dilute sulfuric acid we are adding where? To the water. Take two test tubes filled with water and invert them over the electrodes. Which one? Both the test tube. Now see what happens. We have been taken here. So two test tube filled with water. These are to be inverted. So where? Inserted where? In this rubber. And see students, what happens in this case. So where in this case, if you are supplying the current, so I've been taken a, first of all, water is there, and here we have been taken a two electrodes, graphite electrodes. One act as a cathode, another one act as a anode electrode. And at cathode, what happens? Cathode is nothing but, so it is connected where? To the negative terminal of the battery. Negative terminal of the battery, or source we can say. Negative terminal of the battery. Okay. So in the same way, anode, that is connected where? To the positive terminal of the battery. So this one, whatever that is connected where? To the negative terminal of the battery, that electrode, it act as which electrode? So here I am taking that one as cathode electrode, and the electrode which is connected to the positive terminal of the battery, that act as anode electrode, student. Cathode and anode. Okay. So what happens after passing electric current? 6 voltage we are supplying. Okay. And electrolysis of water, that is in presence of sulfuric acid. To acetylate, we are adding a small quantity of sulfuric acid. That one you have to remember. Okay. Now, thing is that at cathode, if you are going to consider, double amount of gas is collected compared to anode, because during the breakdown of water, 2H molecule is released with one oxygen molecule. Here, when we bring a burning candle to the gas at cathode, it burns immediately, but at the anode, it does not burn, because it is, in this case. So what is get collected, and what about their ratio? That one we can see. So at cathode electrode, which gas is produced? Means hydrogen gas, that one is produced. hydrogen gas towards at cathode. At anode, oxygen gas, that one is produced. Let us see here, this is oxygen, this is hydrogen. In what ratio regarding the hydrogen and oxygen means 2:1 ratio by their volume, that one we can see. This is also one of the example for thermal decomposition reaction. So electrolysis of water, it gives, one is oxygen gas, that is released or produced towards at which electrode? So we can see anode, and hydrogen gas towards at cathode electrode, students. Okay, so this is about for the day. So remaining types of chemical reaction, that one we will discuss where in the next class. Thank you, students.